Rồi ba quay phim rồi đó nha con. Khi nào nó không thấy gì ra báo ai nha.
Good evening. I welcome you from the beautiful city Tel Aviv. I'm very happy to share this online session with you, and I hope that you can hear me well and see me well. In the next hour, I will be discussing digitalization and predictability in guided implant dentistry, focusing on the sequence of work when planning a guided case and the surgical steps to follow. Before I start, I would like to thank my Yes and Dental Tribune for the opportunity to participate in this study club. I will divide my presentation into 3 parts, starting with my perspectives about the advantages of using software and the guide. This procedure is well documented to have high survival rates. But since the first definition of the parameters for successful osseointegration and survival of implants, our perspectives have changed. When we judge the end result, our implants, and when our patients look at the end result, we no longer settle just for survival as satisfactory. We examine the result in high definition, and so will our patients. So today, our definition for successful treatment result is extended. We strive to get a natural appearance for the final restoration. We examine carefully the interface between the pink aesthetics and the white aesthetics. We evaluate the treatment results at the end of treatment, but we expect it to be stable also for the long-term follow-ups. To get all this, we maximize our predictability of treatment results, adopting a structural workflow in every part of our professional work. We have a structured protocol, starting with the way our secretary will answer the phone when a new patient calls in. The music in the waiting room will not just be a random one. And we also have a structured way to analyze a new clinical case, starting with data collection, starting at the patient's level, narrowing down to the tooth level, using x-rays, photographs, and sometimes other means, depending on the need for the specific case. This will lead us to the diagnosis. Like in this case, the diagnosis will be a root fracture in the left central incisor. According to the diagnosis, we set the treatment plan. As for this patient with a fractured root, the primary treatment goal will be to resolve the pathology. But once we extract the tooth, the patient will require restoration to restore the aesthetics and function. So we start to list all the treatment stages according to the sequence determined by the biological needs. We will need to restore the tissue frame, the bone and the soft tissue, to set the ground for proper implant-supported restoration. Only then, after analyzing the data and defining our treatment plan, we start the treatment, always starting by resolution of the pathology. We extract the fractured root. Usually, after the extraction, we can expect damage to the bone envelope. Depending on the duration of the inflammation developed around the fracture and the width of the buccal plate, especially the buccal bone, the thinner the bone walls are, the longer time the patient will have the pathology and related inflammation, the more extent the lesion in the bone will be. We clean the bone bone surface from soft tissue remnants, and augment the bone to restore the tissue frame. Now, considering the peak aesthetics, we know that creating an aesthetic result will require a restoration of the bone frame and the soft tissue dimensions. So in this case, I was using a particulated allogenic bone material and a cross-linked membrane that was fixated with the internal resorbable sutures. But since I work within the bone envelope, then the prognosis of this bone augmentation is quite good. And indeed, we have now a wide envelope to position an implant. Now, when I have such a wide bone, I can decide to position an implant in a certain inclination, or maybe in another inclination. The angulation and position of the implant should be very much determined by the prothetic superstructure. We no longer just put the implant wherever the bone is, but rather correlate it between the bone and the prothetic superstructure to the best implant position. The implant is not just a standalone appliance. We position it according to the surrounding bone and in relation to the shape of the crown and the position of the crown according to the arch and the adjacent teeth. So, number one advantage of using computer implant planning will be the ability for top-down planning, meaning we can use the viewer of the software to virtually plan implant position, not only according to the dimensions of the bone, but also according to the future crowns that this implant should be supporting. Now, when we look at these aesthetic catastrophes, this is not a disease. This is not peri-implantitis, but rather an improper implant angulation that can be avoided using adequate pre-planning. So going back to the wide reach that we have, we can plan to install a 13mm implant. But if we simulate the position of this 13mm implant on the software, parallel to the long axis of the bone, illustrating also the planned restorative framework, then we can see that the axis of the abutment or the opening of the screw is going to come out at the incisor edge of the planned restoration. And we know that for long-term prognosis of our implant and the retrievable restoration, we try to aim for a screw-retained restoration rather than a cemented restoration. So we want to tilt the implant a little bit to the palate. Now we can do that and simulate that on the software. We have the possibility to move the implant a little bit more to the palate in relation to the prothetic frame that we have. And then we can see that what actually happens when we move the implant to the palate, that we are going to have a buccal fenestration in the apex of this implant. And this can be very easily prevented if we are just going to pick a shorter implant, an 11.5mm implant instead of a 13mm implant. So the second advantage of using computer-supported implant planning will be our predictability. By simulating the surgical and the prothetic sequence of work on the software, we can be more predictable in the surgical work and reduce some of the surgical complications and human errors related to the surgical process. Now, we can also plan an instrument to guide our drilling according to the desired implant position that we've picked on the software for a more predictable end result. Using an open template that will not cover the ridges totally will make it easier to reflect the flap during surgery. In this case, at the time of implant installation, I was choosing to augment the soft tissues, to further work on the site preparation for a better pink aesthetics. Now today we can also choose another way to get a screw retent restoration, even if the long axis of the implant is going to come out at the incisal edge of the crown. Instead of changing implant inclination, we can use an abutment with an angulated axis to the screw channel, so we will not need to tilt the implant to the palate. Whenever we have missing bone volume for implant installation, we can augment the bone prior to implant placement or simultaneously with implant placement. Like in this case, it's clear that we have a buccal concavity in the area of the missing teeth. But we can also try to manipulate within the available bone to reduce the extent of the surgical procedure and sometimes the costs. So if we look at the sagittal section in this case, we can position an implant within the bone envelope. But if we look now at the 3D illustration in this specific implant position, we can see that the implant is way too lingual, and this will require some prothetic improvisations or will end up in a very unhappy patient. So again, we're going to use the software to simulate a correction for this implant procedure. If we are going to correct the inclination of the implant according to the central fossa of the medial tooth, what will happen is that we are going to end up with a buccal dehiscence to this implant. That will require some bone augmentation. Now, this simulation will enable us to decide what will be the best compromise in this specific patient, considering the surgical and the prothetic aspects. Without even touching the patient, we can negotiate within the working team what is the best compromise in this case and what we are going to choose, whether we are going to have prothetic improvisations or we are going to have bone augmentation. So the third advantage of simulating the treatment on the software will be the ability to understand what are our compromises. And talking about simulators, so just like a pilot preparing for a flight, going through the pre-planned checklist, so will a dental surgeon preparing for treatment, especially if it's surgery. We are going to follow a structured workflow to be used in computer-supported implant planning and guided surgery. To go digital, first we start with a proper digital file for planning. We gather all the data by which we are going to plan the implant position. It's important to have a high-resolution information to allow better calibration of our data. This part of data collection is the most important part to get an accurate end result. After uploading all the data on the software, we can virtually plan implant position, taking into account all available information. But in this planning session, we are also going to plan the template, the guide design. And this should take into consideration also our surgical plan, because we're going to have different guide designs depending if it's a flapless procedure, if we're going to raise a flap, and if we're going to use distal stop, and I will go through some examples in the upcoming slides. Eventually, the surgical procedure is going to integrate all the previous stages of the workflow. But since we already simulated everything on the software, it will be much faster and more predictable, minimizing the human errors that we might have during surgery. This part will also require a structured workflow, according to the recommended protocol, to maximize the benefit that we can get from a guide. So let's just look a little bit into details within this digital workflow. Starting with data collection. when uploading a new case on the software, we need three kinds of database. We need the original format of the CT scan, the DICOM files, a digital model of the patient's mouth. We can either use an intraoral scanner, which already produces the digital STL file, or we can take conventional impressions, prepared as cast models, and then they are going to be scanned to perform a digital file. Now, impression taking is going to be performed the same way we are going to take them for final restorations. Very, very accurate. With also careful casting with no air bubbles, since the guide is going to be built according to this cast model or according to this impression taking. So it's crucial to make it very accurate and precise. Now the third component will be the wax-up. This can also be produced digitally using different softwares like Exocad, or we can go with a conventional way, having a wax-up the same way that we know it, and then we're going to scan it using a laboratory scanner, which is very accurate, to produce a digital file to be integrated within the software. So we have all these three pieces of information uploaded on the software, creating a file for us to plan. Now, using the software is very simple and user-friendly. We have the bone imaging from the CT scan. We have a digital model that we took from the impressions or scanned from the cast model. And in this case, we had also a digital wax-up. We choose on the screen the position of the implant that we are going to place. Here we are going to place an implant in the missing second premolar, opening a dialog box to pick the implant dimensions, length and width. And now we just start to move the implant in space according to the available bone and the wax-up. We can change it in the bacolingual dimension, in the mesiodistal dimension. We can relate it to the available bone and also to the frame of the restoration, future restoration. And we can easily change the dimensions of the implant on the software if we initially picked improper ones. Like in this case, we're going to shorten the implant, not to get into the maxillary sinus. Now, when we have all implants planned, we can virtually create a template, a guide, to guide our drillings into the correct position and angulation of the implant as we plan them on the software. This virtual instrument can be printed in a 3-dimensional printer to become a real instrument to be used during surgery. Of course, this is being fabricated from a biocompatible material. We will design the guide to be very stable on the tip and on the tissues, because if it's going to be moving or rocking, then we cannot count on the end result. We cannot count on it to drill our guides to the correct position of the implants as we plan them on the software. So calibration going from the software back into the patient's mouth is going to be very important. We are going to design the guide according to the anatomical situation and according to the treatment plan. If we are going to be supported only by teeth, then the guide design will be quite simple. If we plan to manage a flap during surgery, then we can design the part that is going to be reflected as floating above the area of the flap manipulation. In fully dentures cases, we are going to have full support from the soft tissues, but most of the cases we have partially with teeth partially edentulous. Usually the posterior teeth are going to be missing, and in these cases we are going to have some tissue stops at the distal part of the guide. Now, the position of these tissue stops is going to be picked according to the surgical plan. If we are going to reflect the flap, then we are just going to position these distal tissue stops further away from flap reflection. And we should also take into consideration the anesthesia when we are going to perform it, because we don't want to change tissue volume in the area of these tissue stops. It's crucial to make sure that the guide sits in place in a very stable way. It should have a stable positive sit on the teeth. And if we have just the slightest rocking on the teeth, then we need to go back to the stage of impression taking. Because whenever we have improper impression, then we might have a problem of improper positioning of the guide. And usually if we go back, take a new impression, and create a new guide according to that, then this problem will be solved and we can count again on a good calibration. Working digital and creating a guide for surgery will not require a different process, just a different sequence of work. Most of our efforts will be invested in pre-operative planning, and the surgery itself will be very focused and fast because we know where we are going to go and how we are going to get there. Following the drilling protocol, keeping the drilling very passive, not pressing hardly against the guide and by that changing its position in space, and ensure a very predictable result. Using a guide, we have to consider the bone temperature during drilling. It was concluded that the use of a low speed of drilling, up to 800 RPMs, combined with external irrigation, of a fluid that is being cooled to 10 degrees, we can result in a very minimal temperature change to the bone method. Now, if we are going to use an open guide that will improve our ability to reach the bone with a cooling solution, of course we can prevent even further from overheating of the bone. But depending on the bone density and our biological knowledge, sometimes we do need to have additional cooling, and after every exchange of a drill, we are going to insert a cooled solution into the osteotomy to prevent the bone from overheating. After describing our structured digital workflow to be predictable when choosing computer-supported implant planning and guided surgery, let's just summarize all of this through a clinical case. This is a patient that came to our office after diagnosed with external resorption in both of the central incisors. We plan to extract both teeth, restore the tissue volume, and restore the missing teeth with implant-supported restorations. In these cases, where we need bone augmentation together with implant installation, we prefer to wait 6 to 8 weeks from extraction to the next surgical procedure to have better soft tissue manipulation. So first, we just extracted the left incisor, leaving a buccal shell of the right incisor, just for temporary preservation of the bone peak in the central papilla area, and waiting 6 weeks for soft tissue closure. During that time, we could carefully plan implant installation. We started just according to the workflow that I've described, uploading the CT image, the model of the patient that was taken with an intraoral scanner in this case, and we also had a wax-up. Having all these pieces of information, we can now upload everything on the software and start planning. As described, I'm picking the 2 central incisors. I'm going to pick the dimensions of the implants that I want to have, and now just start very fast to position the implant according to the available bone and according to the frame of the planned restoration. I know that I'm going to aim for a screw-retained restoration, so I want to try to have the opening of the screw in the cingulum of my restoration and not in the incisor edge. And I know that I'm going to have bone augmentation in this case, but I'm going to try to have it simultaneously to the implant installation. So I'm changing the position of the implants in the mesiodistal dimension and also in the vertical dimension and bacolingual dimension to have it parallel one to the other, to have it parallel to the roots of the adjacent teeth, and to have a proper exit of my screw opening where I want it to be and not in the incisor edge. Now I can just enlarge one of the windows to have a better vision of everything. And once I'm happy with the end result of my planning, I can also check the position of the abutments and plan a template, a guide, that will position my implants in the correct angulation and position during surgery. This is going to be printed in a 3-dimensional printer. You can also see the stops that we created on the laterals to prevent from the guide to rock to the buckle aspect when we are going to press against the guide during drilling. And since the whole framework of the guide is going to be floating and open, I can clearly see the bone while drilling and make sure that I'm in place, double checking my planning also during drilling. So eventually the surgery itself goes very fast. And I'm also inserting the implants through the guide. This gives me an advantage of keeping my axis also while inserting the implants. And eventually my end result is going to be very predictable, just as I planned it to be. Now, as I knew from the beginning, I'm going to have a very big dehiscence for both implants, so I'm going to have bone augmentation at the same procedure, again using allogenic particulated material and the collagen membrane that is going to be fixated with internal sutures. Now, after healing, I'm going to have a wide envelope of bone and soft tissues that we can start working on the wide aesthetics. What can we expect when we are using a guide? If we look at the literature, then the numbers are quite acceptable. To make it better, it will be very much depending on the precision in our work during the data collection, the planning, and the surgery itself. We know that each case presents with its own unique challenges. Since every case is different, starting with the patient demands, going through the biological requirements that will demand a customized treatment plan. But despite this, I would like to conclude drawing some guidelines to follow when we consider computer-assisted implant planning. Today, dentistry is no longer just a one-man show. We work in a team, where each member of the team performs within the scope of his or her specialty. And also we look at the treatment as multidisciplinary, meaning that each part in the treatment will prepare the basis for the next step. And all steps will fit together to create a full, detailed picture. So, one of the basic concepts of having a predictable long-term result will be to plan implant position according to the prothetic superstructure. We're going to use the software to simulate the surgical treatment plan. Rehearsing and practicing our cases will improve the result in the real-time test during surgery. Turning our case through this simulation will reveal problems needs to be solved and compromises needs to be made. So we are going to negotiate these compromises prior to setting the final treatment plan. We're not just going to deal with covering our mistakes after they're already being done, but we're just going to try to prevent them by proper planning. Now, despite the differences in each case and the constant need for improvisations in our clinical work, it is very important to keep a structured workflow. We're not just going to take shortcuts. There is an importance for every step to set a proper basis for the one to follow. Adopting a digital workflow will integrate the use of new technologies, new instruments, scanners, guides, digital articulators, and so on. New technologies, new instruments, and other innovations should be adopted, but with respect to prior knowledge, keeping the biological principles. Now, keeping these two principles will ensure a predictable result, both mechanically and biologically. With this, I would like to thank my team members for our daily fruitful collaboration, and to thank you for listening for this presentation. I hope you've enjoyed it, and let's see now if there are any questions.
Cảm ơn quý bác sĩ đã tham dự trọn vẹn buổi học ngày hôm nay. Mọi câu hỏi liên quan đến bài giảng vui lòng gửi về địa chỉ email chăm sóc khách hàng.ad@ddd.vn. Bác sĩ của MIS sẽ trả lời sớm nhất qua email cho các bác sĩ ạ. Và tiếp theo chương trình, chúng ta sẽ đến với bốc thăm trúng thưởng dành cho những bác sĩ hiện đang có mặt ở trong phòng. Mỗi bác sĩ sẽ sở hữu cho mình một con số may mắn, và nhà nhân viên 3D đã nhắn riêng cho các bác sĩ. Các bác sĩ hãy lướt qua để xem lại con số may mắn của mình. Các bác sĩ nào, nếu mà các bác sĩ nào chưa có cái con số của mình thì hãy giơ tay lên trong phần participant, thì nhân viên 3D sẽ liên hệ trực tiếp với bác sĩ. Hiện tại trong phòng của chúng ta có 29 bác sĩ, nên em sẽ nhập số từ số 1 và tới 29 và bắt đầu quay số ạ. Không biết còn bác sĩ là chưa có con số may mắn của mình không ạ? Các bác sĩ mình đã có đầy đủ con số của mình rồi.
Xin lỗi.
Tinh thần cho thời đại dịch không đủ. Bởi vì khi nhìn được kiểm soát vẫn đang rất là
Cái này nó có đèn rất màu vàng.
Quay số của chúng ta sẽ quay 22 lần và cũng như là thử lần thứ hai để
Như thế nào? Bây giờ thay cái này là cái thay vào cái ổ này là luôn ạ. Đây là nặng đâu hả?
Lượng quay thử lần thứ nhất là con số 16 và chúng ta sẽ đưa vào vòng quay chính thức. Có một con số 1 và con số tiếp theo là chúc mừng bác sĩ đang sở hữu con số may mắn số 10. Để trúng giải, nhân viên BD sẽ liên hệ chủ động với bác sĩ để trao giải thưởng ạ. Giải thưởng là một cây Implant V3. Giải thưởng này có giá trị trong vòng 1 năm và các bác sĩ sẽ không được quy đổi thành tiền mặt. Không biết bác sĩ đang sở hữu con số 10 có mặt ở trong phòng không ạ? Bác sĩ sở hữu con số may mắn số 10 có mặt trong phòng không ạ?
Con hai đại cô Tâm là
Nhân viên BD liên hệ với bác sĩ đang sở hữu con số 10.
Cảm ơn anh.
Để giúp cho bạn được cải thiện tốt lượng sau xin bác sĩ dành một số thời gian để hoàn thiện các hậu quả đại sát của BD.